topic is the topic is displacement current density. Displacement current density. Sorry, displacement current density. Right. So we know that for static fields from the Ampere's law, Ampere circuit law, del cross H is equal to J. Whenever current flowing through the wire, magnetic field is developed. So, for the relationship between the magnetic field strength and current density, that is del cross H is equal to J. From the Ampere circuit law we can write. So this first equation. So apply divergence on both sides. Simply put del dot on LHS side and del dot on RHS side. So that is del dot del cross H del dot J. Right. So there is one vector identity. So del dot of del cross A. So A is any vector, so that is 0. So del dot del cross H is equal to 0, so del dot J becomes 0, right? So there is continuity equation says that del dot J is equal to minus dou rho V by dou T. So two equations are not compatible. Here del dot J equal to 0, here del dot J is equal to something. So it is possible, so it is not possible. So two equations are not compatible for time varying conditions, time varying magnetic fields and electric fields, time varying fields. These two equations are not compatible. So we have to modify very first equation. Modify very first equation. So this is very first equation, del cross H is equal to J. We have to modify this one. So this equation is modified as del cross H is equal to J plus JD. JD is added. So what is JD here? JD is the displacement current density. Displacement current density, right? And J is the conduction current density. Conduction current density. Sorry. So J is not conduction current written, but it is wrong. J is conduction current density. Apply divergence theorem to the equation 4. Simply put del dot on LHS side and right side, RHS side, del dot del cross H. It is nothing but automatically 0. So del dot J, del dot of J plus JD, it will become del dot J plus del dot JD. So del dot J plus del dot JD equal to 0. So del dot JD becomes, what happened? Del dot JD becomes minus del dot J, right? So we know that del dot J is equal to what is that? Minus dou rho V by dou T, right? So we know that del dot T is equal to rho V from the Gauss law, we already derived. So del dot JD, so del dot JD equal, we can write rho by dou T. In the rho V place, we can put del dot D. So take the differentiation inside. What happened? Del dot JD equal to del dot dou D by dou T. Now compare this equation on both sides. So JD equal to, we can write dou D by dou T, right? So you have to substitute this equation JD equal to dou D by dou T in fifth equation. So del cross H is equal to J plus JD. In the place of JD, you have to write dou D by dou T. So dou D by dou T. So this is the Maxwell equation for a time varying field. The term JD dou D by dou T is the displacement current density. So that is rate of change of electric flux density. What is actually J? So J is nothing but conduction current density. So this is about displacement current density. That is JD equal to dou D by dou T.